All right, for this problem, the very best thing to do in a situation like this is to draw yourself a picture. So I'm going to draw a square. And of course, in doing so, the best thing for me to do, I'm going to do A, B, C, and D. And I'm going to mark all these, that they are all congruent, and that I have all right angles. Then off of those squares, it says on one side, I'm going to put the point P so that CDP is an equilateral triangle. So if I put point P here, I'm going to end up with CDP as an equilateral. Well, to mark that, since this side is already marked with 1, I'm going to mark those two with 1 as well. And then I'm going to put point Q so that BCQ is an equilateral. So my point Q would be up here. I'm going to mark those as well. Now that we have the scenario, we have the situation all laid out for us, we need to figure out how to show that A, P, and Q is also equilateral. So A to P to Q, that this is also equilateral. All right, so looking at this, one of the things that I noticed was that since these are all equilateral triangles, the two triangles that we drew, we know that the angles are all 60. So this angle would be 60, this would be 60, 60, and 60. I also notice that I have 3 triangles where the pink side that I'm trying to prove are congruent happen to be the longest side. And these 3 triangles are all isosceles triangles. So I'm going to use some ideas from that to see if I can prove those 3 triangles are congruent. In looking at this, I see that angle B, the big angle B, or angle QBA, has a total degree measure of 90 plus 60, or 150 degrees. I also notice that angle ADP is in the same boat because it's 90 plus 60. With that being said, I know that triangle QBA has to be congruent to triangle ADP by side, angle, side, because I know that AD, DP are congruent to QB and AB, and then I also know that they have an included angle between them of 150 degrees. So now we need to try and figure out if we can show that angle QCP is also equal to 150. If it is, then that triangle is also congruent to the other 2 triangles, and we'll be able to use CPCTC to say that all 3 sides have the same length. So in looking at this, I notice that around this vertex C right here, we have a 90-degree angle and 2 60-degree angles. Now I know around any point we have a total of 360 degrees. So if I take 360 and I subtract the 90, I get 270. And then if I take off the 120 that the 260-degree angles equal, I get 150. So therefore, QCP also equals 150 degrees. So I can add to my congruent statements over here that triangle QCP is also congruent to the other 2 triangles. If all 3 triangles are congruent, then I know by CPCTC that QA is congruent to PA is congruent to PQ by CPCTC, which makes triangle APQ equilateral.